In this video, we're going to look at analysing the rising main system in Flowmaster v7. We can see the system here in front of us. On the left hand side, I'll now zoom in. We have our sump, which has a gauge attached, and that feeds through to these three pumps in the pumping station for the feed pipe work. And follows a single rising main here, which goes with 0.3 metre pipe. Each of these pipes here is 50 metres long. From here it goes to this junction where there are two feeds, one to a low level reservoir and one to a high level reservoir. We're going to look at a model where two events happen. The first is we are controlling this valve here using this tabular controller. What we're saying here is that between 5 seconds and 6 seconds the valve will close. The second event is happening under control from the rest of the system. Attached to the sump we have a gauge here, and each of the pumps is controlled by these square yellow controllers. Passing data in and out of these, we have a controller here, in there is a script, and this reads the pump levels and sets the logic states of the pumps accordingly. Using the data from over here, at the pumps, first pump will trip at 1.5 metre, second pump will trip at when the level is 1 metre. We'll now run our analysis. We'll run the analysis for 15 seconds, with a time step of 0.05 seconds. And when the analysis starts, we'll also get two runtime graphs showing the data from the analysis as it progresses. On the top graph, we can see the pressure downstream of the junction. On the second graph here, we can see the blue line, which is the sump level, which is gradually dropping, and the blue and green, red and green lines are the logic state of the pump. Currently, the logic state has just changed, so the red line on pump number 2, you can see it's moved from logic state -1 of running at a constant speed to logic state 0, meaning the pump has stopped. You see the second pump still allows the pump level to drop, but the pressure at our junction starts to drop, and then we can see a reflected pressure wave as the system starts to stabilise. If we look at the bottom graph, we can see that the rate at which the level in our sump is changing, the rate has dropped, so the tank is now emptying more slowly. These runtime graphs can be used to reproduce any results in Flowmaster during the analysis, and after the analysis the results can be brought back in from Flowmaster using the standard graph tools. So we're moving towards the 5 seconds where we said that the valve just downstream of the junction will close. It's feeding the low reservoir. So we can see as the valve closes, between 5 and 6 seconds, the pressure will start to drop quite quickly as the momentum of the fluid draws the fluid up the line towards the reservoir. The pressure will drop. We'll now reach the vapour pressure, at which point a cavity will form. After a period of time, that cavity will collapse. We'll then get a high pressure peak as the fluid faces change velocity. So here you can see the pressure peak caused by the cavity collapsing. Then, as the fluid returns, again we get a further vapour cavity. The analysis will now be run to the finish, and we'll look at the results within Flowmaster. First of all, we'll zoom in to the area around the node at the junction. And we look at the results at this point here, which is the results that we're coming back on the graph. So we can open the results up, and then we can look at the results. First of all, we look at the pressure at node level result. You can see here how the pressure roughly continues, with small spikes caused by the pump tripping, and then we get the larger spikes as the analysis progresses. If we select the overlay button, we can then plot the results for cavity volume, and also for the flow through the valve here. And we can see, if we go back back to the graph, you can see the red line is the cavity volume. So when the pressure reaches the vapour pressure, the cavity starts to form, it then collapses. This causes high change in velocity at the face, and we get the high pressure peak that then dies off, and we get the slowly decaying cavities. And if we ran the simulation further, eventually the pressure will settle back down to the maintenance pressure. You can also see here how the flow drops a bit when we trip the first pump. As the valve closes, the flow decays. Actually, the cavity starts to form when the flow drops to near zero. We can also look at these results as a plot versus time. I'll first clear the collection. Then I've created two layers. The first has the components between the pumps and the T-junction here, so I can add that to the collection. And the second has the components to the low-level reservoir go through this valve here. Once I've added those components to the collection, I can go to my Result Audit tab, select the results that I want to look at, and click on the Pipe Profile Viewer. This will take me to this dialog here. I can select the node at the start or the end. I know my system starts at node number 42. And Flowmaster here, what it's done is it looks at the line and worked out how the components connect together. It will find the fluid density from the fluid, and will select the gravity. If I wanted, I can change that. And I'll say I'll look at this between 0 and 15 seconds. If I click on the OK button, I'll get a graph that changes with time. So I'll just pause this while I explain what's going on. We have the red line. This shows the maximum head in the system. We have the green line here. This shows the minimum head in the system through the time of the analysis. We have the blue line that shows the level. And all of these are versus the chainage at the bottom. We also have the component numbers and node numbers at each point reported. This is the area around the junction where there are several components and nodes with no length. Finally, we have this pink line, which initially, with both pumps running constantly and no change in. The system remains roughly constant. But as we trip the pump first and then close the valve, we'll see that that line starts to move. And eventually, we'll cover the entire range between the maximum and minimum pressures. So here we can now see a small amount of movement as the pump trips. We can now see a small pressure wave passing up and down the pipe caused by the check valve closing upstream of the pump. That will eventually be damped by the system. Now we are getting near to 5 seconds, at which point the valve will start to close. What we'll see now is that the pressure starts to increase on this side and decrease on this side of the valve. So the valve is at this line here. At this point, the 2 points diverge and the system is effectively isolated by the valve closing. So you can see we have one pressure system over here and another system on the right hand side of the valve. So in a second we'll see the valve cavity collapsing. That will cause the high pressure here to go all the way up to this point here. You see that pressure wave passing up and down the line. The low pressure wave following behind. If required, we can also change the time step interval and how long we wait between frames if we want to speed up or slow down the results. We can also look at the results from certain from a fixed time step using the result button here. So if I go back and reopen my plot window, I can select a certain time, so it might be able to look at 9.5 seconds, and I can get the graph at that point in time with all of my lines, and if I want, I can export that as a, in this case, bitmap, save it to a file,